Start, yeah.
Right. So, hello everyone. I'm Girish and that's Vijay. We're from Freshworks. So, Freshworks is SaaS application startup out of Chennai. We first started out by building customer support software, and over the years we have branched out to building, adjacent software like, chat softwares, marketing software, and stuff like that. So right now we're a suite of products, and we've been, Redis Labs customers for a while. Today we're going to talk about one infrastructure in our, application stack, and that's the API Gateway. Right. So first off, why do we need an API Gateway? So the way it's structured is that generally, if you're building a business application, you have clients on one side, and you have your application on the other side. Every request that a client sends goes through multiple decisions that your application layer has to decide on, like authentication, authorization, and rate limiting. And then there is your application logic that comes up. So predominantly, as our business grew, we saw benefit in having all of these authorization, authentication, and rate limiting, separated from the application layer. And that is typically what we call as the API gateway today. So when a client sends a request to any of our servers today, there is an API gateway in the middle that mainly takes these three decisions: authentication, authorization, and rate limiting. For today's talk, we'll probably focus a lot on the rate limiting aspect of the API gateway. So before we start talking about what our rate limiting logic is, I'll walk you through a couple of decisions that we've taken on how we built the API gateway. So predominantly, if you look into the market to see what are possible API gateway solutions that are available, you'll probably come across Envoy, and then there's Istio, and then there's Kong. So we evaluated all of these API gateways that are available, and we've decided that Envoy works best for the Freshworks infrastructure. There are a lot of reasons that went through this whole decision-making process. Key aspect is that Envoy is very simple. Istio is something that's built on top of Envoy, and it is cloud native and for Kubernetes, and we weren't on Kubernetes then. And it just felt like, Envoy just felt like a pretty good fit. So Envoy basically is a proxy on which you can build all of your API gateway decision-making services. Right. So I'll just walk you through, Freshdesk, which is one of our products, which is the customer support product. I'll walk you through how our infra looks, and I'll tell you where the API gateway fits into this. So typically, every request lifecycle starts at the ELB, which is your load balancer, and then it goes through an HA proxy layer. The HA proxy layer is a proxy that decides which application server the request has to get routed to, and then you have your application machines. A very brief summary would be a client sends a request, it hits the ELB, and then it goes to the HA proxy, and then the application server receives the request. So where does the API gateway fit into all of this? So Envoy per se has two modes in which you can operate. So Envoy works as something called as a sidecar, and it can also work on the edge. So how are they different? Sidecar basically means that for every app instance, there's another instance of Envoy running along with the machine. Whereas when you're talking about Envoy on the edge, that's not the case. The Envoy machine is separate, and the application server is separate. There are a lot of business-related reasons for why we chose Envoy to be a sidecar. Typically because we wanted to take rate-limiting decisions for every one of our application servers. So if I wanted to walk you through the request lifecycle right now, it would go to the load balancer, it will go to the HA proxy, and then the request would come to Envoy, which is in the same instance as our application server. Now in Envoy, you have this concept known as filters. You have a lot of HTTP filters that are available. What we're making use of today is known as the rate limiting filter. So when a request comes in, the rate limiting filter will send this request to another server that we've written called as the rate limiting server, where a decision on whether this request needs to go through or not is taken. So what we've done from where we were and where we are right now is that we've decoupled the decision-making of whether a request should go through or not from the application server to this rate-limiting server. Now, how does that help us? Basically, because we're a multi-product company, we don't want to replicate this rate-limiting logic in the application server in all of our applications. So if you have a centralized rate limiting server, it's just available out of the box for any new product that we're building. And that was the main thought process behind having a rate limiting server. So the rate limiting server, internally we call it Fluffy. So those of you who watched Harry Potter, Fluffy is the three-headed dog that basically prevents you from going into, which basically prevents you from going inside the trapdoor. So Fluffy is Freshworks' API Gateway, and it basically prevents bad actors beyond a certain limit to go inside, to reach the application server. So that's our guardian dog there. So what does Fluffy basically do? So Freshdesk, like I mentioned, is a SaaS product. So you have this concept called accounts, as in everyone who signs up for a Freshdesk account gets an account, and you can configure rate limit policies differently for each account. So there are two basic aspects that Fluffy has to do. One, it has to store the rate limit policies for every account, and for every incoming request, it has to maintain a running counter of whether, how many requests have taken place so far. So at the moment that it identifies that you've used up your rate limit counter, it basically rejects the request and doesn't allow the request to pass through to your application server. And these are the two main things that Fluffy does. So now we can talk about where Fluffy basically fits into the whole Freshdesk architecture. So here, a Freshdesk, I'll just walk you through the different components here. A Freshdesk application server is basically the upstream server. Now, as you can see, all of a cluster of application servers contain an instance of Envoy running there. Now, when a request comes through, Envoy basically calls via a network load balancer the Fluffy's rate limiting server. Now, before all of this, when someone signs up, their request via the FreshOps admin reaches the Fluffy admin server and creates a rate limiting policy for them. So once you have a rate limit policy that's configured via the FreshOps admin, and when a request comes in, it looks up to see which account is the request for, and basically takes a decision on whether this should pass through or not. Right. So Vijay will now explain how we use Redis Labs in all of this. I've basically just talked about what Fluffy is.
Yeah. So thanks, Girish. Right. So because we're just before lunch, I'll try to keep this very short. So we don't have any more slides after this. It's just numbers. So, that's good news. So I'm mostly going to talk about So this portion, the application server, the rate limiting server, and how it interacts with Redis. So in terms of what Redis calls we make, we try to keep it very simple. My overarching goal is always simplicity over anything else. If things don't work, that's fine. It has to be simple because, if it doesn't work and it is simple, you can, hopefully figure out why it's not working. So the only things we do here, the rate limiting decision making server is, in Java, and it's a native-based server. So the intent over here is that everything be very low latency. So this is a long-lived connection, and so once the connection is established. Connection establishment time takes about 2 milliseconds, but after that it stays on. So there's only network transfer time, and since we are deployed in all the regions that use this, that time is practically zero. And then the time from our application server to Redis itself is about 0.4 milliseconds, right?
Yeah.
So what happens is every time we get a call, we do certain things like, okay, we have to look up, is this account, how many calls is this account allowed to make in a minute? So let's say that's 100 or something. So we'll get that from Redis. Then we'll check. Okay, so let's make an increment call on Redis, saying, okay, let's bump up now +1, and then we'll get, when you say increment on Redis, it'll give you back what the new number is. So you say increment and the key doesn't exist, you will get 1 and 2 and so on. So when we get that, if we'll compare, okay, so the count now for some account is, say, 85 or something, and we'll check with their account policy. If it's less than what they're allowed to make in a minute, we let them go. I mean, we let them through, so then like, okay. So, comes here, we say okay, and then it goes all the way here, and if it says okay, then the envoy lets the call go through to the app server, and then, the app server does the business logic. Now, if the call exceeds, their limit, then, we just say, again, the interface, the semantics are defined in Envoy, between Envoy and this interface over here. So we'll say no, and then Envoy basically will not forward it and will return, HTTP 429. So it's really that simple. Now, there is one thing that we added over here, which is that Redis allows you to add Lua scripts. You can write a custom Lua script that you execute against Redis, and you just pass the arguments to it. So that is the only customization we made, or the only additional feature of Redis that we use beyond the most basic get, expire, TTL, and hget all, right?
Yeah.
So why do we need that Lua script? So one of the things I personally love about Redis is the fact that it's single-threaded, and that someone thought to write a single-threaded application in 2009 was, I think, very courageous, and it has to be. It's wonderful that it's worked out so well, and I think a lot of Redis' success is again because of its simplicity and the call not to take fancy bells and whistles. So now what we do is originally we used to say, like I said, we'd say increment for some account, we'd increment, and we'd get the count back. And if the count was 1, that means that this is the first time we are seeing this account. So if the count was 1, we would say, okay, expire this key in 60 seconds. So it worked for the most part. But then in one case, what happened was we made the call to increment. The response didn't come back to us. We got an error in the response. And because of that, we never set the expiration on that key. And because we never set the expiration on that key, the counter kept going up, 100, 1,000, and so on. And so what happened was an account which should have, after say a minute or so, after they should have been rate limited, they were never rate limited. And I think for an hour or so, all their calls just, failed. So that's why we brought in the Lua script to do this. The Lua script does both increment, does the if check, and then does the, conditionally does the expire. And that's the only complex part that we added to our use of Redis. So, okay, now let's look at the numbers. So this is like, as of, I think, December, we get on average, 30.8 million requests in a day. And, most of the time people don't get, sorry, I pressed the wrong button. Most of the time people don't get rate limited. And anyway, so these are our numbers. So these are our end-to-end numbers. So what, the Envoy on that end to us and back. So as you can see in the various regions, these are the numbers we have. Our P99 is consistently, under 2 milliseconds. P999, where, Girish is mostly working on it. But yeah, so, question then is, why are we, why is it so good? So like I said, this is the get call we make to Redis Labs, and in US East, which is our most trafficked region. So the maximum that we see is less than 0.4 milliseconds. So how do we keep to less than 2 milliseconds? Make sure that for any of our calls, we do not make more than 5 calls to Redis for any operation, and we're under 2 milliseconds. So, I mean, that's basically it. The out-of-the-box instance, like we use with Redis Labs today, it gives us 25,000 operations per second, and like currently we are doing about 12,000 operations per second on our side. Though right now we are only rate limiting API traffic that our products get. Moving forward, we will start taking all of our web traffic, and that, we hope to, exceed 25,000, and then, then we'll really test if Redis Labs' auto scaling works. But yeah, that's it. Thanks.
Great. Thank you very much.